Okay, let's see. Let's start off with x1, y1 is equivalent to x2, y2. That means x1, y1 is equal to lambda x2 lambda y2. So if you divide by lambda, you can say 1 over lambda x1, 1 over lambda y1 equals x2 y2, or in other words, you can say x2 y2 equals 1 over lambda x1, 1 over lambda y1. And then to make it really clear, you could say let lambda equals 1 over lambda. So then you get x2 y2 equals lambda x1, lambda y1, or in other words, x2 y2 is equivalent to x1 y1. So that's true. That's the reflexive one. Sorry, the symmetric one. Let's check the reflexive one. Is x1 y1, is that equivalent to x1 y1? Well, does x1 y1 equal lambda x1 lambda y1? Yes, it does. Lambda equals 1. So sorry, maybe I should make this a bit clear. Given that, we can conclude that does that equal that? In other words, does that equal that? Yes. And in fact, you can say lambda equals 1. That's the situation. True. Now, the trickier one, well, actually, maybe it's not trickier, the transitive one. So, given that x1, y1 is equivalent to x2, y2, and given x2, y2 is equivalent to x3, y3, that means you can say x1, y1 equals lambda x1, lambda 1 x1, lambda 1 y1. And also you can say that x2, y2 equals lambda 2 x3, lambda 2 y3. So, oh, sorry, that should have been x2. That should have been y2. Okay. Right, so I basically kind of you can kind of rearrange these a little bit. So what you can arrive at is also saying 1 over lambda 1 x1, 1 over lambda 1 y1 equals x2 y2. And then if x2 y2 equals lambda 2 x3, lambda 2 y3, we can then say 1 over lambda 1 x1, 1 over lambda 1 y1. That's equal to lambda 2 x3, lambda 2 y3. So that means we can say x1 y1 equals lambda 1 lambda 2 x3, lambda 1 lambda 2 y3, and we can say let lambda equals lambda 1 lambda 2. So then we get x1 y1 equals lambda x3 lambda y3, or in other words, x1, y1, we can conclude that x1, y1 is equivalent to x3, y3. That's true. So uh, that is proven. What are the corresponding equivalent classes then? Okay, let me clear this off. So let's take an example. Let's say, oh, like the equivalent class of, I don't know, 1, 1. So that would be all the points x, y, just as an example, all the points x, y, where you could say x, y equals, let's make it a bit more interesting. Let's say 1, 2, at least 1, 2, where x, y is equal to lambda 1, lambda 2. So this actually looks like, we're going to draw it. There's the point 1, 2. And it'd be all the multiples of 1, 2. So it'd be all the points along this line, except for 0. And the lambda, can it be positive? A non-zero real number, so it could be negative. So yeah. Yeah, I think that's what it looks like. So it's all points on the line from 0, 0 to 1, 2. So I guess if that's the case, it's enough. You can partition or squared, oops, into the equivalent classes x, y, where x, y is on the unit circle. I think that would do it. So like if you take all these points on the unit circle and then get their equivalent class, so that would be all the points on the line from 0, 0 outwards. Oh, actually, I don't even need to do the bottom half. It's just on the upper uh, half of the unit circle, because you'll get the negative ones as well, like that. Yeah, I think I have that under geometrical understanding correct. So hopefully I do.